Hello students, I am Sonali Kelkar from City International School, and today we are going to do the third chapter of chemistry, that is metals and non-metals. The syllabus that we are going to cover in these session of this chapter are properties of metals and non-metals, reactive series, formation and properties of ionic bond. So let's start the session. Now let's start with the recap, students. Okay, so let's do the definition of metal. Elements which are having 1, 2 or 3 valence electrons can be drawn into wires, beaten into sheets, are lustrous and good conductor of heat and electricity, are called metals. Now metals are electron donors and can form positively charged particles called cation. For example, metal lose valence electron to achieve stable configuration, and thus they form positively charged particles known as cations. Now let me explain you this with example. We can take an example of sodium here, right? And we know that sodium is going to lose one electron and it will form a cation, that is Na plus. Right? Now let us make a configuration, electronic configuration of sodium. We know that sodium, atomic number of sodium is 11, so we can arrange it in a shell, that is 281, right? And this one electron can be loosened by sodium to attain a octet state, that is if it loses one electron, if one electron is loses, then it will form a state that is 2 and 8. So 2 and 8, you can see there are 8 electron in the outermost shell. And what is the outermost shell is called? That is called valence shell, and the electron that are present in outermost shell are known as valence electron. Okay, now let's take a few more example quickly. Magnesium, Mg, right? And what is the configuration of magnesium is 282, because the electron atomic number of magnesium is 12, so that is why I have arranged those 12 electron in a 3 shells, that is 2, 8 and 2. Now this magnesium is going to lose 2 electrons so that it can attain a octet state, that is 2 and 8. Here 8 electrons are present in the outermost shell. These 8 electrons are known as valence electron, and this state is known as octet state. Let us do with aluminium also, Al. Okay, now what is the configuration of aluminium? 2, 8 and 3, because atomic number of aluminium is 13, right? And if it loses the 3 electron, what will happen? It will again attain a octet state, that is the number of electron in the outermost shell is 8. So this is called octet state. So if you see over here, these elements are losing one electron. Here sodium has lost one electron, magnesium has lost one electron, and aluminum has lost 3 electrons. So the elements which are having 1, 2 and 3 valence electron, and they loses these valence electron to form cations. These type of elements are metals, right? Now coming to the types of metal, number 1, noble metals. Why they are called noble metals? They are highly unreactive metals. And what are the noble metals are? Silver, platinum, gold and palladium, right? Now alkali metal, they are present in the first group. Student, I hope that you know what are group. The vertical columns in the periodic table are known as group, and the horizontal rows are known as period, right? So the first group is made up of alkali metals. So they are highly reactive metals, and with low melting points they are soft, for example potassium and sodium. Then alkali earth metal, This is the second group in periodic table, alkaline earth matter. They are less reactive, higher melting points and harder than alkali metal. For example, calcium, magnesium and barium. Now coming to the transition metals, they are hard, they are shiny, they are strong and easy to shape. For example, iron, chromium, nickel and copper. The fifth part, that is the other metals, they have diverse properties. For example, aluminium, gallium, indium, tin, thallium, lead and bismuth. So these are the different types of metal. Now coming to the definition of non-metals. Non-metals, I'll take laser pointer. Non-metals, the definition of non-metal is elements which are having 5, 6 and 7 valence electron and cannot be drawn into wires or beaten into sheets, are non-lustrous and poor conductor of heat and electricity, are called non-metals, right? Here there has to be written, non-metal has to be written here, right? So I'll just cut it and write they are called non-metals. Non-metals, right? So non-metals are electron acceptor. Okay, metals were electron donor, whereas non-metals are electron acceptor and can form negatively charged particle because they accept electrons. So definitely they are going to form a negatively charged particles because the number of electron will increase after accepting the electron. The number of electron will increase, and we know that electron has a negative charge. So definitely if they are gaining more electron, the charge will get negative, and negatively charged atoms are known as anions. For example, non-metals gain electron to complete their octet. Okay, so in case of metal, we have seen that they are losing electron to obtain their octet state, and non-metals are gaining electron to obtain their octet state. Why they want to go for octet? Why? Okay, why they want to go for octet? Because octet state is the most stable state. It is the most noble state. Even we as a human being, we want a stability in our life. We want to be financially strong. Okay, we want our family to be well maintained. We should have a good health. So that is a stable state. So even you can see these properties in metal and non-metals, which always try to attain a stable state. Okay, a stable state can be attained when they have 8 electrons in their outermost shell. And what is the name of outermost shell? What do we call? We call as valence shell, and the electrons which are present in the outermost shell are called valence electron. Okay, so let's go ahead, and they get converted into negatively charged particle known as anions. So negatively charged particles are called anions. So let's take few examples of non-metals also, right? So let's start with the fluorine. Fine. Fluorine, as we know, it is a non-metal, and non-metal has a tendency to gain electron. So that is why I am putting a plus sign here. Electron E negative. Why I have put a negative sign here? Because electrons are negatively charged particles. So what is atomic number of fluorine? Atomic number of fluorine is 9. So atomic configuration will be 2 and 7, right? So it need one more electron. That's it. So if they need one more electron, that is why I have written plus electron. After gaining an electron, the configuration will be, fluorine will be 2 and 8, right? So this is gaining electron, and what will be the charge? Because it has gained electron, so charge will be negative. So they become negatively charged, right? So they become anion. Let's take the case of oxygen. Oxygen configuration is 2 and 6. So oxygen require 2 electrons. So plus 2 electron Okay, it gives me oxygen, that is O minus 2. You can write either minus 2 or 2 minus. Okay, and what will be now? It is 2 and 8. Now the octet state is formed. Okay, here in case of in case of okay in case of let's take nitrogen, right? So nitrogen, the configuration is 2 and 5. What is the atomic number of nitrogen? That is 7. Okay, so 5 electrons are present in the valence shell. So to form a octet state, it needs 3 electrons. So 3 electrons are added, and nitrogen is now become N minus 3, that is nitrite, and the electronic configuration is now 2 and 8. Okay, shall we take one more example, that is chlorine, Cl, right? Now the chlorine atomic number is 17, so 2, 8 and 7 comma 7, and it requires 1 electron, so plus I can write 1, or even if you don't write 1 over here, that's fine. So 1 electron is added to chlorine. It has become Cl negative. This is chloride, which is an ion. Which type of ion? Anion, because it is negatively charged. And the configuration is 2, 8 and 8. So this is all about metal and non-metal. Let's take the differences of metal and non-metal. Children, now let's see the difference between metals and non-metals. Because we have already done this in our previous slide, in our previous session, as well as in previous slide also. I'm going to take just a gist of this. I want you to write this table in your notebook properly, and so that it will be as a note remaining with you for your exam. Okay, for the reference. So you have to write a note of this table. Now let me take this. I am not going to do it in detail, so I'll just take a few important points and we will go ahead. Now coming to the physical property of metals, metals are solid except mercury. Metals are hard except lithium, potassium and sodium. Metals have metallic luster, that means they are shining in nature. They are malleable, ductile. They have high melting point except gallium and cesium. Metals have high boiling points. Metals are good conductor of heat. Best conductor of heat is silver and copper, and poor conductor are lead and mercury. Now metals are good conductor of electricity. The best conductor are silver and copper, and metals are sonorous. Coming to the non-metal, non-metals may be solid, liquid or gases. Most of the non-metal are gaseous in state. Some are solid, and one, that is bromine or bromine, is liquid in state. Non-metals are soft except diamond, which is the hardest natural substance. Non-metals do not have luster except iodine crystals. There's a little spelling mistake over here, just avoid it. Non-metals are not malleable, non-metals non-ductile. Non-metals which are solid and liquid have low melting point. Non-metals which are solid and liquid have low boiling point also. Then non-metals are bad conductor of heat, and they are bad conductor of electricity except graphite. Non-metal are not sonorous. So coming to the next point, that is chemical properties of metal. Here reaction with oxygen. We know that metal react with oxygen, most of the metal. Maximum number of metals react with oxygen to form metal oxide. Now let me take pen, and we again have to write few things over here. So metal plus oxygen, we can write here metal plus oxygen. Shall I write O2 instead of whole spelling of oxygen? Gives metal oxide, gives metal oxide. So if we see the metals given in our book, metals These are copper will react with oxygen, and when copper is heated, it combines with oxygen to form copper oxide. This copper oxide is black in color. So because it is heated, I have to put a triangular sign here, right? So this is a delta which represent a heat. So a copper is heated in air, it combines with oxygen to form copper 2 oxide or copper oxide. It is a black oxide. This is very important. Black color is very important because they do ask in exam that which color of copper oxide is formed. So it is black color. Black color. It is very important from the point of view of exam. You need to write. So black color oxide is formed. When aluminium is heated, it combines with oxygen to form aluminium oxide. Now you have to write this equation also. That is aluminium plus oxygen. It is heated. Again, I have to put a sign, that is delta sign, heated, and it forms aluminium oxide. So you can see that we have already done copper oxide react with hydrochloric acid, and we have learned that metal oxide are basic in nature. Okay, how can we say that metal oxide is basic in nature? Okay, let's see a few examples. So when sodium react with oxygen, it gives you sodium oxide, right? Now we can write one more example, that is lithium react with oxygen gives you lithium oxide. These are the extra equations we are doing. Lithium oxide Li2O, right? Now we have to balance the equation, that is it will become 4 here, 2. Okay, so definitely lithium oxide. Potassium with oxygen gives you potassium oxide, right? Sodium with oxygen gives you sodium oxide. Now these oxides are basic in nature. How they are basic in nature? To determine that, we have to dissolve this sodium oxide or the oxides of metal with water. So when oxides of metal dissolve with water, we are getting hydroxide of metal, that is NaOH. Na2O plus H2O, we are getting NaOH, right? So NaOH is alkali in nature or basic in nature. We can write basic in nature. So these hydroxide dissolved in water gives alkali, which is basic in nature. Potassium oxide dissolved in water gives you potassium hydroxide. This is also basic in nature. Sodium hydroxide and potassium hydroxide, they are strong bases. Some metal oxide shows acidic as well as basic nature. This is very important point. This is an important point. These are called amphoteric oxide. Amphoteric oxide, because this oxide shows acidic as well as basic property. Now what are these oxides are? These oxides are aluminium oxide and zinc oxide, right? Aluminium oxide and zinc oxide. Now let's take one by one. Aluminium oxide, that is Al2O3. Why it is Al2O3? Aluminium has the valency 3 plus, oxide has a valency 2 negative. You have to avoid sign. When you just cross multiply, I am getting Al2 and O3. Okay, so this is aluminium oxide. Now it is showing acidic as well as basic property. So let us prove this. When aluminium oxide react with acid, okay, when you react aluminium oxide with acid, so definitely I am getting a salt and water, right? So this property, this reaction is neutralization reaction. So neutralization reaction will act when base and acid mix together, right? So I'm getting salt. This is salt, right? This is a salt, and that is aluminium chloride, and water is formed. Now when I react aluminium oxide with base, When I'm reacting aluminum oxide with base, again I'm getting a salt. This is sodium aluminate. This is a salt and water is formed, right? Now let's balance this equation. This is not the balanced one. 2NaOH over here and 2 over here. So now this equation is balanced. So we can see that aluminum oxide is acting as a base as well as an acid, because it is giving salt when it react with acid as well as when it react with base. Here let's see the reactivity of different metals with oxygen is different, right? We have observed, we actually there is an activity and we have to do that activity in the class. But when you do this activity, you will come to know that metals do not react with oxygen at the same rate. Okay, some metals react very vigorously with oxygen and it catches fire, that are potassium and sodium, and that is the reason they are kept under the kerosene, or they are stored in kerosene to prevent burning. Here you can see in the picture lithium, sodium and potassium. These are alkali metals and they comes in the top at the top in the reactivity series, and they are highly reactive metals, right? So in air, what do? They absorbs water molecules which are present in air, and they produce a lot of heat because that is a highly exothermic reaction, and this heat will help hydrogen to burn. Okay, and that is why they are kept under the kerosene oil. We know that hydrogen is quite flammable gas. Okay, and that amount of heat which is produced by the absorption of water molecule from the atmosphere, that is enough to catch hydrogen to catch fire, and oxygen is present in the atmosphere which definitely supports fire. So that is why these metals are stored in kerosene. Now let's see the magnesium. Magnesium is heated. When heated, it burns with a bright flame, as you can see in this picture, right? And coming to the iron, when you heat iron rod, it glows brightly. But what happens when you heat iron filings? So if you heat iron filings, you can see this picture. In this iron filings, they are burned with a bright flame, right? Now if copper is heated, it doesn't burn, but it forms a black coating of copper oxide. Here you can see the black coating of copper oxide. Okay, then coming to the silver and gold, we know that silver and gold, platinum, these are very inert metals. They don't react at high temperature with oxygen. There are some metals like magnesium, aluminium, zinc and lead, etc. They form oxide layer over it, which prevent it further oxidation. So there is a layer of oxide, as we have seen in magnesium oxide also. Aluminium, zinc, lead, these metals, they form an oxide, and this oxide layer of metal, it prevent them from further corrosion or further oxidation. So they have a quality which is known as self-protecting qualities. That is why they are called as self-protecting metals. Now children, let's take reaction of metal with water. So let me take a pen first. Now before we start the reaction, I want to tell you, when metal react with water, for metal I am taking M, when metal react with water, it gives metal oxide it gives metal oxide plus hydrogen gas. So I'll write H2 here, right? Now this metal oxide react with water. This metal oxide further react with water, that is H2, and now it is going to give us metal hydroxide. And Here you can see metal oxide plus water. This metal oxide react with water, the remaining water, and it gives us metal hydroxide. Now I have taken a reactivity series here. Why? Because these all metals in the reactivity series, they are in a increasing or decreasing order of reactivity series. That means the upper element, that is potassium, sodium, calcium, potassium, sodium, calcium, they are highly reactive metal. Magnesium, aluminium, zinc, iron and lead, these are less reactive element, and the element which are below the hydrogen, of course they are least reactive elements. Now regarding the reaction of metal with water, let us divide this whole series into four parts, right? Now potassium and sodium, they are very reactive element, highly reactive element. They are highly reactive element, and they react in cold water. So potassium and sodium, they are highly reactive. The reaction is highly vigorous. The reaction is highly violent or vigorous. It evolved a lot of heat, that is why we call it highly reactive or vigorous reaction with cold water. So you can imagine with cold water, if the reaction is so vigorous, you can imagine what will happen if they react with hot water. Okay, you can't even try to put these metals in a hot water. That will be a very explosive reaction. Now let's take the reaction of sodium and potassium first. Okay, now when I add sodium and potassium, let's take a beaker, and in this beaker water is there. If I am adding sodium or if I am adding potassium here, sodium or potassium, what will happen when I add sodium and potassium in water? Hydrogen gas will be released, H2. This gas will released. Okay, so these sodium and potassium, they are very light, they are very soft and very light metals. They are going to float on this, on water. They are going to float on water. Now this hydrogen gas will be released, and there is lot of heat is released. That is why it is a vigorous or violent reaction. Hydrogen gas plus lot of heat is released. This heat is going to burn hydrogen gas. This heat is going to burn. So as a result, what will happen? This hydrogen gas will burn, and when it burn, definitely the sodium metal or the potassium which is floating on the water, sodium or potassium which was floating on water, that will also catch fire. That will also catch fire, and the sodium will burn with yellow flame or golden yellow flame, right? And potassium will burn with violet or purple flame, right? So that is the reason we don't keep sodium and potassium in open. They should be stored in kerosene, right? Because this hydrogen gas is very flammable gas. It is very flammable gas, and the heat which is evolved will definitely make hydrogen to catch fire, and when the hydrogen catches fire, the potassium and sodium which is floating on water, that will also catch fire. So this is highly exothermic reaction. Now coming to the calcium. Now calcium, if I add calcium in water, what will happen? If I add calcium in water, okay, calcium will first go and settle down at the bottom. Okay, the calcium will first go and settle down at the bottom, but due to the release of hydrogen gas, because the hydrogen gas is releasing over here, these bubbles of hydrogen gas, these are bubbles. Okay, the bubbles which are released in this reaction, the bubbles of hydrogen which are released in this reaction, the calcium particles will stick to the bubbles, and definitely it will come and it will float on the top, right? So calcium will float. Again, this calcium is also reacting with cold water. So the first three metals react with cold water. These three metals react with which type of water? Cold water, right? Cold water. But the thing is, potassium and nitrogen, potassium and sodium, that reaction will be highly vigorous reaction, violent reaction with a lot of heat, and this will definitely going to catch fire. Hydrogen will catch fire first, and then because of the hydrogen, sodium and potassium which is floating on the water, that will also catch fire. In case of calcium, calcium will first get settled down, and then when the hydrogen gas is released, the bubbles of hydrogen gas, okay, calcium particle will stick to the bubbles of hydrogen gas, and it will come and start floating at the top. So in the next moment you will see that these hydrogen particles, these calcium particles will come up with the hydrogen bubbles, and it will start floating later on. Is this an exothermic reaction? Yes, it is an exothermic reaction. Heat is produced in this reaction, but the heat is not enough to cause fire. Okay, it is not enough to cause fire. So it is a exothermic reaction, but heat is not enough to cause fire. So in case of calcium, the calcium will float. I'll write here float. It will float on the water. Okay, now coming to the aluminium, zinc and iron, right? Now in the case of potassium, sodium and calcium, I just want to write the reaction here, potassium, sodium and calcium. Okay, potassium plus water is going to give me potassium hydroxide, KOH plus water, KOH plus hydrogen gas is evolved plus heat. Children, then comes sodium. Sodium plus water. Here you will see sodium hydroxide, NaOH. Sodium hydroxide is formed, hydrogen gas is released with heat. Clear? This is violent reaction. Okay, exothermic reaction. I'll just write violent reaction. So you will see fire at the top. Coming to the calcium plus water, it is also going to give us calcium hydroxide, CaOH, calcium hydroxide, OH whole 2. Hydrogen gas is released, and because of the hydrogen bubble, calcium will stick to the hydrogen bubble, and it will float at the top. Heat is also released, but it is not that. So it is not. The heat is not that much, so that it causes calcium to catch fire. So, okay. So heat is not sufficient enough for hydrogen to catch fire. In fact, the hydrogen should catch fire first. So heat is not sufficient enough. I'll write here not sufficient I will erase it, children. So the heat produced during this reaction, during the reaction of calcium with water, it is not sufficient. It is not sufficient for hydrogen to catch fire. Clear? Now in this case, the calcium hydroxide which is formed, it is a little milky in color. It's milky, right? This solution is milky. Now coming to the Next, aluminium, zinc and iron. Why I'm just leaving calcium. We are going to deal with the calcium later on because little different. So let's take aluminium, zinc and iron. These metals do not react with cold or hot water. They react with steam. Aluminium, zinc and iron, they react with steam. They react with steam. Okay, they don't react with neither cold water or hot water. So let's take the reaction of aluminium. Now when I writing the reaction of aluminium, when aluminium react with steam, that is H2O, then aluminium oxide is going to form. Al2O3, aluminium oxide is going to form with release of hydrogen. Same with zinc, Zn plus H2O, zinc oxide is going to form ZnO with the release of hydrogen gas. So hydrogen gas is released here. In case of iron, when iron reacts with water, okay, this is a reversible reaction. It is giving me Fe3O4 and hydrogen gas is released. Now if you see here very carefully, aluminium, zinc and iron, when react with water, they are forming oxides of metal. Here the oxides of metal are forming. They are not forming hydroxide. In case of potassium, sodium and calcium, hydroxides were formed, and in case of aluminium, zinc and iron, oxides are formed and they reacted with steam. So I'll just write steam over here. They didn't react with hot water, neither did they react with cold water, but they react with steam and they are giving rise to hydrogen gas. Now we have to balance the equation. 2 aluminium, 3 H2O, right? And the rest over here is 3H2. Zinc, this is already balanced, and coming to this, and 3Fe plus 4H2O gives me Fe3O4 plus 4H2. Now this reaction of iron with steam is a reversible reaction. Now in case of zinc reacting with steam, when it is hot the color is yellow, and when it is cold the color is white. So it's not given in your book, just for the extra information I have told you. Now let's see with magnesium. What happened with magnesium? So when magnesium react with hot water, magnesium reacts with hot water. So let us write over here, magnesium reacts with hot water, and when it reacts with hot water, what is formed? In NCERT it is given that when magnesium, that is Mg, reacts with water, this what type of water? This is hot water. I'll write hot beneath, right? This reaction is not given in your book. Magnesium hydroxide is formed. MgOH whole 2. Magnesium hydroxide is formed with the release of course, hydrogen gas. Okay, so in NCERT they have written magnesium hydroxide is formed, but if you see in other books or even in Wikipedia, they have written that magnesium oxide is formed with the release of hydrogen. So that's fine. And all these reactions are very important. Now what about the lead and copper, mercury, silver, gold? These metals, they are not reacted with, they doesn't react with water in any form of water, whether it is cold, hot or steam. So here there is no reaction with water. Okay, no reaction. No reaction with water. Clear? Now if I write the reactivity order of metals towards water, so let me write the reactivity order of metal towards water. Potassium is highly reactive, then comes sodium, then comes calcium, then comes magnesium, then aluminium, then iron, then Pb, then copper, then Ag, and then comes Au. Ag is silver, Au is gold. So this is the reactive order of metals towards water. So this is all about the reaction of metal with steam. So which metals react with steam? Aluminium, iron and zinc react with steam. So you can see the hydrogen gas is collected, and here is water. It is this is gas is collected. Why hydrogen is collected at the top? Because hydrogen is very light gas, so it is collected in this manner. Let's see the reaction of water. Reaction of metal with water, we have already done. Sodium with water, NaOH, H2. Potassium with water, KOH, and H2 is gas is released. Calcium with water, calcium hydroxide, and hydrogen gas is released. Aluminium and iron, they react with steam. They don't react with cold water or hot water. So we can write here steam. Okay, even this is iron reacts with steam. So we have already discussed that it is a reversible reaction, and the different details are also given over here. Sodium and potassium react violently with cold water to form sodium hydroxide and hydrogen and catches fire. And calcium reacts less violently with water to form calcium hydroxide and water and does not catch fire. Magnesium reacts only with hot water to form magnesium hydroxide and hydrogen gas. Metals like aluminium, iron and zinc react only with steam to form metal oxide. This is very important. Metal oxide and hydrogen. Metal like lead, copper, silver, gold do not react with water. So they shows very least reaction with water, or they don't react with water at all. So I hope students you understood everything. I have told you everything in detail. Please practice today's topic, and thank you so much.